Ever really stop and wonder where your digital life actually lives? All your private messages, your photos, every bank transaction, it's not just floating around in some cloud. It's all stored inside these massive invisible fortresses. So today, we're going to pull back the curtain and see how these digital fortresses are built, and even more important, how they're protected. All right, let's get into it. Really think about it. The banking app on your phone, your social media accounts, all that online shopping history, that is some seriously personal information. It has to be stored somewhere safe, right? Somewhere organized and somewhere that's accessible to you, but locked down tight from everyone else. So where exactly is that somewhere?
Well, the answer is the very foundation of our entire digital world, the database. And just like any good fortress, it all starts with a rock-solid base.
So, what exactly is this foundation? A database. But don't think of it like some messy junk drawer. Oh no. It's much more like a high-tech library, where every single piece of information has a specific place. Its whole job is to keep your digital treasure perfectly organized and secure, so you can find what you need in a flash.
Okay, but a fortress isn't just a big stone box, right? It's got rooms, hallways, a specific layout. It has a blueprint. And it turns out, the way we organize our data has a blueprint too.
And the most common blueprint you're going to see, by far, is something called a relational database. The easiest way to picture it is like a huge, perfectly organized spreadsheet. You've got tables, which are like the different sheets, and in those tables, you have rows and columns, just like you'd expect. It's a beautifully simple, powerful, and crazy efficient way to store information.
Now, here's where the real magic happens. Look at this diagram. It's a simple database for a gym. You see how the members table connects to the member signups table? And that table connects to the class schedule? This is the relational part of the name. It's what lets the database create a link, a relationship between you, the member, and that yoga class you signed up for on Tuesday at 6. It's this beautiful web of interconnected information.
All right, our fortress is built, and all our treasure is neatly organized inside. What's next? Well, we've got to secure the main gate, right? We need guards. In our digital world, this is called authentication. It's the very first security checkpoint. Think of it like a bouncer at a club whose only job is to look at your ID and ask, "Are you really on the list?" Before they let you pass that velvet rope, they have to be sure you are who you say you are.
And we've got a bunch of ways to check that digital ID. There's the classic password, which is kind of like a secret passphrase. Then you've got Multi-Factor Authentication, MFA, which is like needing the passphrase and a special keycard. Single sign-on, or SSO, is like having one master key that gets you into several different buildings. And certificate-based authentication, that's the equivalent of a digital royal seal that's impossible to forge. Okay, great. You've proven who you are, the guards have let you in the main gate, but that doesn't mean you get to just roam freely through the entire fortress. Now we have to talk about which rooms you're actually allowed to enter.
This next critical layer of security is called authorization. This isn't about if you can get in anymore, it's about what you can do now that you're inside. Do you have the key to the library? Are you allowed in the treasury? Or are you stuck in the main hall? So remember this, authentication gets you through the front door. Authorization decides where you can go from there.
Let's make this real with an example. Imagine we have a user from the HR department, and they need to access the employee files. This line of code right here is basically how we hand them the keys. We're telling the system to grant the ability to select, which means to read, and insert, which means to add new records, on the employee's table to our HR user. Simple as that. They now have the key to read existing files and to add files for new hires.
But hey, what if that person's job changes? Maybe they're not in charge of hiring anymore. Well, with another simple command, we can revoke their insert permission. We've just taken that one key away. They can still read the files, but they can't add new ones. It gives us incredibly precise control. Now, as you can see in this table, there are a few different strategies for managing all these keys. With discretionary access, the owner of the file gets to decide who gets a key. Mandatory access is super rigid, where the system itself enforces strict rules. Think military-level security. But the most popular one for big organizations is role-based access control, or RBAC. Here, you don't give keys to a person, you give them to a job role. So if you're an HR manager, you get the HR keys. If you move to finance, you swap them out for the finance keys. It's clean, efficient, and it scales really well.
So, how do you actually manage all of this without going crazy? Well, there are a few core rules, some best practices that every good Fortress administrator lives by.
And the absolute number one, without a doubt, most important rule of them all is this: the principle of least privilege. This is the golden rule of all security, period.
And the idea is actually incredibly simple. You only give someone the absolute minimum level of access, the fewest number of keys they need to do their job. Nothing more, nothing less. You wouldn't give an accountant the key to the server room, right? And you definitely wouldn't give the master key to the whole castle to a summer intern.
And beyond that golden rule, there are a few other key practices. First, you've got to regularly check for old, unused keys and take them back. Don't leave them lying around. Second, use that role-based system we just talked about. It's just a smarter way to work. Third, encrypt your data. This is like writing all your secrets in a code that only you can read, both when it's just sitting in the vault, that's data at rest, and when you're sending it by messenger, that's data in transit. And finally, you have to keep a super detailed logbook of who goes where and when. That's called auditing, and it's how you spot if anyone's been snooping where they shouldn't be.
So there you have it, the foundation, the blueprints, the guards at the gate, and the keys to every room. That's what makes up our digital fortresses. But when you boil it all down, it all hinges on one simple concept: trust. Because every single time you log in, post a photo, or check your bank balance, you're handing a copy of your keys over to someone else. The real question isn't just if they're keeping them safe, it's what happens when they don't.